Okay, it's recording, I think. I'll share the screen. And you can see the screen now?
Yes, I can see.
So it says Maths Academy. All right, here's some hidden things. What do we got here? Aha. Naomi said to me a while ago that I need to remind you to send your trig investigation by the end of today,
Okay.
if you haven't already done so. Okay. You're in a position to do that? I won't ask anymore. She's asking me to do that. Okay, what else? I noticed you weren't using graph paper. Have you got access to a printer?
Mm?
Do you have access to a printer at home?
No, I don't have, but I have
All right.
paper.
You're at school. When we finish the meeting, I'll come out and I'll give you some graph paper, okay?
Okay, okay.
You remind me at the end of the lesson. Okay. And the other thing, you may be expecting a trig test next week, but it's not going to be. We're going to put that off a week. And I think, Linda will tell you tomorrow, I think you're going to have the other topic test, okay, next week.
Okay. Okay.
Okay. All right. So this is what we're talking about today, the general tan function, like this, just like the sine one, where A, B, C, and D are parameters. Fortunately, though, in the tan one, we only have to look at B and C. We don't worry about A and D, okay? So generally, we look at this one, y equals tan B of x, and we see what happens to the graph when we change B. Well, it's just like it is in a sine and a cosine. This is a horizontal dilation with a scale factor of 1 on B. So it's all compressed by a factor of B. And just like in the sine function, where the new period was 2 pi over B, because the period of tangent is pi, now the period just becomes pi divided by B. So when we look at this is your basic tan graph. The period is pi, because here's one complete cycle. Period is pi. And the asymptotes is the first asymptote, pi and 2. And the next one is at 3 pi and 2, one period apart, and so on. So there's your basic tan graph, which in your lesson notes, I asked you to learn how to sketch. And I've just got Desmos here to plot tan of 3x. And now you can see there are 1, 2, 3 complete cycles in pi. So the new period is pi on 3. Pi divided by the number here, of course. And now the asymptotes, well, you can just find where the asymptotes are by dividing each of these by 3. Pi on 2 divided by 3 is pi on 6. And then it's k lots of the period, which now is pi on 3. So you can see the first one here is at pi on 6. I've done my usual thing of having one square is pi on 6, yeah? So there's the first asymptote. Next one is here, which is pi on 3 along, 2 squares. And then another 2 squares, another 2 squares, another 2 squares, okay? So they're the ideas that we use to sketch a graph that we might want, like this one's the example from your textbook. We want to sketch y equals tan of 2x between negative pi and pi. So now I'll go through that on the board. Oh, there's Ty. You there, Ty? Can you hear me, Ty? Hello, Ty.
Hi.
Hi, Ty. How are you?
Yeah, I'm good, thanks.
You're good. Okay. April and I just started the lesson. All right. I'll say some things to you when we've finished, but we're trying to learn how to draw now graphs like this of y equals tan of 2x. I'm recording this, so you'll be able to check up on anything you missed out on before, but I'm about to jump up from a table here and go to the board and show you how to go about drawing y equals tan of 2x. Okay?
Yep.
So I've drawn up some axes from negative 2 pi to 2 pi. But we only want it from negative pi to pi, actually, so I don't need it that far. But I've chosen the usual scale. 1 square is pi on 6. And then we know that the period of tan is pi. We know the asymptotes occur at pi on 2 plus k lots of the period. So for tan of 2x, the period is going to be pi divided by 2. And the asymptotes are going to occur at pi on 2 divided by 2. In other words, pi on 4 plus k lots of the period, which is now pi on 2. So the first thing we do is we mark in the asymptotes. So the first one is at pi on 4. Pi on 4 is 1.5 squares, right? This is pi on 2. Pi on 4 is here. So I draw in that asymptote. Always in these, draw your asymptotes first. The next one occurs pi on 2 along from that. Now pi on 2 is 3 squares, so counting 1, 2, 3 is going to be here. If I need to go on beyond pi, I'd count again 1, 2, 3 squares, but we don't need that. Going back 1, 2, 3 squares. Here's another asymptote. Then 1, 2, 3 squares is your last asymptote in the domain that we want. So we've done the asymptotes. Next thing you do is work out where the tangent is 0. Well, when x is 0, tan of 2 times 0 is tan of 0, which we know is 0. So certainly we've got this one is 0. Where else will there be a 0? Tan of, well, the best way to think about it is to use the period, pi on 2. The next 0 is going to be pi on 2 along, so 3 squares, here it is. And the next one, 3 squares along, here it is. And going back, 3 squares, going back 3 squares. That's where tan of x equals 0. Now, what else do we know? We know that tan of pi on 4 is 1. So that's tan of 2 lots of pi on 8 is 1. So we know that at pi on 8, we're going to have the value of 1. Now, where's pi on 8? This is pi on 4. Half of that is going to be about here. So that's going to have the value of 1. And so if I make this 1, and this minus 1, negative 1, then pi on 8, 1 is a point. Again, using the idea that the period is pi on 2, counting 3 squares, 1, 2, 3, will be another place where there's 1. And then 1, 2, 3, you're outside the domain, so we don't plot it. Going back, 1, 2, whoops, we should be 1, 2, 3 is 1. Okay. We know that tan of negative pi on 8 is going to be negative 1. So here, counting 3 squares along, 1, 1, 2, 3. 3 squares along, 1, 2, 3. We need that one. Going back, 1, 2, 3. No, sorry, got 1, 2. Yeah, all right. 1, 2, 3. No, we're outside the domain then. So that's all that we need. We've done the asymptotes, we've done the x-axis intercepts, and we've put this common point on. Now we can draw the graph. Arrows on the end to show it continues forever and ever. This bit we only need here. Here we've got a full cycle. And here we have what? Did I miss one out? Did I? Yes, I did. I should have kept going here. 1, 2, 3 here. So we can draw the graph there. There's our graph of y equals 2x. Any questions about that? Thumbs up from April. Min, you okay? Thumbs up too? Good. Okay. Well, that's good. Just one more thing to do today. The other thing we focus on in the 10 is just changing C. And that, of course, like in the sine and cosine, is a horizontal translation of tan through C units. So again, I've just drawn a graph here of using Desmos of tan x. And then this one, I put in tan of x take 1.6. Why did I do 1.6? Well, pi on 2 is 3.142 roughly divided by 2, which is 1.57. It's roughly 1.6, isn't it? So really, what I've done is pretty much y equals tan x take pi on 2. So C is pi on 2, means it's a translation of pi on 2 to the right. And you can see that that's happened because this point here has moved to there. Pi on 2 to the right, 3 squares. Yep. Every point on this graph has been moved pi on 2 to the right. Even the asymptotes, this is the important thing for our drawing to see, is this asymptote here at pi on 2 has moved over to here to pi. In other words, it's moved right by pi on 2. So we could say the new asymptotes are pi, which was the first one's gone to, plus k lots of pi. Well, that's just saying it's an integer number of pi, isn't it? So when we put that into practice, if I want to do this one, this is what we know about tan x, its period and its asymptotes. So tan of x plus pi on 4, because now we've got c equals, whoops, c equals negative pi on 4. Because this is like tan of x take negative pi on 4. The period here is pi again, and the asymptotes now will be at pi on 2 take pi on 4, moving it to the left pi on 4, plus k lots of pi, because the period is still pi. In other words, it's pi on 4 plus k lots of pi. So again, first of all, we draw the asymptotes. The first one is pi on 4. Here it is. It's the one that was at pi on 2 here. Dilated or compressed by a factor of 2, it goes to here, doesn't it? Okay, and the next one's going to be pi along. Now pi is 6 squares. So 1, 2, 3, 4, 5, 6. I have a problem here, and that my axes are not correct, are they? I don't have enough room for that. Bear with me while we try and fix this up. What can we do? Can we move this right over to here? We might even get away with it being there. So 1, 2, 3, 4, 5, 6, there is pi. 1, 2, 3, 4, 5, 6, there is 2 pi. 1, 2, 3, 4, 5, 6, there is 3 pi. Now we've got it on the correct domain. And we would have put some numbers on the axes. Bit unusual to have 4 squares is 1, but we'll do it. 1, 2, 3, 4, negative 1. Labeling our axes, y and x is done. Now we're in a position to draw it. As I was saying, the first asymptote is at pi on 4, which is 1.5 squares. The next asymptote will be pi along from that, in other words, here. And the next asymptote, pi along from that, which will be here. That's the asymptotes. Okay, next thing we do, like in the other one, is the x-intercepts. the x-intercept that was here has gone 1 on pi and 4 to the left, so it's gone to there outside our domain. The one which was at pi has gone 1.5 units to the left. The one was at 2 pi has gone 1.5 units to the left. The one that was at 3 pi has gone 1.5 units to the left. So there are our x-intercepts. And other nice values, well, if you put x equals 0, tan of 0 plus pi and 4 is just the tan of pi and 4, which we know is 1. So I can plot this point here. Again, using our period of pi, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Whoop. Oh, there we go, of course. 0, pi, 2 pi, and 3 pi. What about the negative ones? Well, they're halfway in between those. So we can plot them. Yeah, that's looking right. This one should be here. Just lost my way there for a minute. And the next one should be here. And we stop the graph there because that's all the domain we want. We don't continue it on up to the next asymptote. Well, there we are. That's the graph then of tan of x plus pi on 4. Give me a thumbs down for that one, eh? I'm sorry about the mistakes there. But do you understand the basic way we do it? Asymptotes first, then x-axis intercepts, then the special point. And wow, you haven't given me thumbs up for that. Thank you, thank you, thank you. You understand that. That's good. Okay, well, that should be enough for you then to do all of text page 186, exercise 7D. Okay. If you've got any problems with that, email me and maybe I can help you via email or some way anyway. Okay. I'll stop the sharing and I'll